So this is a video of me going over similarity and transformations, Unit 6, Section 3. So the first thing I'm going to do is go over some warm-up that cycles back to old knowledge. So I want to ask you first, it says find the image point when the indicated transformation is applied to the given pre-image point. So we're looking at number 1, and it's 2, 4, and it shows us that the transformation is x plus 3 and y minus 1. So if you recall, that transformation is a translation and plus 3 means it's 3 right, and minus 1 means it's 1 down. Now when we apply that transformation, it produces, when we add 3 to 2 and subtract 1 from 4, we get 5, 3. Number 2, the transformation of negative 2, 1 is x negative y. When I taught this, I taught my students that when there's a reflection over x, it changes y, and when there's reflection over y, it changes x. So we see a change in y here. So this is again a reflection over the x-axis because it's a change in y. This time we're just going to change the value, the sign of the y value, and so that's negative 2, negative 1. Number 3, we're multiplying both x and y by 3. So this is a dilation by a scale factor of 3. So we multiply both parts by 3. That gets us negative 15, 0. The last one is also a dilation. This one is a reduction actually, because it's less than 1. It's between 0 and 1 actually. So this is a dilation by a scale factor of 1/3. So when we multiply by 1/3, it's the same as dividing by 3, and 3 divided by 3 is 1, and negative 6 divided by 3 is negative 2. So those are cycling again back to old knowledge about all the transformations that we learned about. We didn't include rotation here, but 3 of the 4. So our objectives today are that I can draw and describe similarity transformations in the coordinate plane, and that I can use properties of similarity transformations to determine whether polygons are similar and to prove circles are similar as well. So our vocab was similar polygons, similarity ratio, similarity statement, and similarity transformation. So again, going back to old knowledge, when I talked to you all about similar images, I said that they were the same size, the same shape, but not the same size. When we talk about similar polygons, the two conditions for polygons to be similar are that first, all their angles, corresponding angles, have to be congruent, and all the corresponding sides have to be proportional. When we talk about similarity ratios, it's when we compare corresponding side over corresponding side, and it produces a ratio or a fraction that relates the two sides to each other. Similarity statement, when we write similarity statements, we do this by comparing the congruent angles. So when we do that, we make sure that the angles that are congruent appear the same place in the statement. So if I were to tell you that triangle ABC is similar to triangle DEF, that tells me that angle A and D are congruent, angle B and E are congruent, and angle C and F are congruent. Thus, they would appear in the same places in those similarity statements. The last thing on here is similarity transformation, and that's what we're going to go over today. A transformation that produces similar figures is a similarity transformation. It's a dilation, or a composite of one or more dilations and one or more congruence transformations. Two figures are similar if and only if they are in a similarity transformation that maps one figure to the other figure. So when we talked about dilations, when I taught y'all dilations, we know that if the number is greater than 0, then it's a dilation. And if k, which is our scale factor, is between 0 and 1, then it's a reduction. So that means it's either a fraction or a decimal. If k is greater than 1, then the dilation is an enlargement. So again, when we are talking about this, we're talking about similarity transformations, has to do with a combination of dilations, one of which would be or a combination of dilations and congruence transformations. The congruence transformations are translation, reflection, rotation. The combination means somewhere in the mix there's a dilation. So we remember also that translations, reflections, and rotations are congruence transformations, whereas the dilation produces a similar figure, not a congruent figure. Here's our first example, example 1. So what you guys are supposed to do on this is go ahead and plot A, B, and C. And when you do that, you should get this figure that's in black on the board. So ABC is our original figure, and then we're going to dilate ABC by 3. So we're going to multiply 1, 1 by 3, that would get us 3, 3. We're going to multiply 3, 1 by 3, that would get us 9, 3. And we're going to multiply 3, 2 by 3, and that would get us 9, 6. So that's where our new points are here, 3, 3 for A prime. B prime is 9, 3, and C prime is 9, 6. Those are our new points. And I want you to notice that it says here that this is a dilation with a center of 0, 0 and a scale factor of 3. The way that we find the center is we can actually draw a line from one. Let's see if I can do this. I don't know if I can do this with my straight edge, y'all. So I'm just going to show you on the board. So basically, when I connect with a straight edge, my vertices that are corresponding, it gets us over here to this point over here. We're going to do this with all 3. We're going to draw, again, another straight line. I would use a straight edge to do this. And from this one as well, a straight edge. And where those 3 intersect, that is our point of dilation. So it's got this is a dilation with a center of 0, 0 and a scale factor of 3. We know it's a scale factor of 3 because that's what we use to dilate it. But I want to look at this image and see if there's another way that we can verify that. So if you notice down here, this side AB right here was our original, and it was 2. And our new side here, AB prime, is 6 wide. And if we divide 6 by 2, our new shape by our original shape, that equals 3. Now if we look at the other side as well, we notice that our original side here, BC, was 1. And up here, BC prime is 3. And again, if we take our new shape, our ABC prime, and we put 3 over our original shape, ABC, we see that our scale factor is 3. With example 3, I want you guys to go ahead and plot P, Q, and R. And then we're going to talk about, I'm going to show you guys how I do when I multiply by a fraction. So when I'm dealing with P prime, I'm going to go -8, and I'm going to multiply it by 3. That's my top part of my 3/4, and I'm going to divide it by 4. That gives me for P prime -6, because the top part is -24, and -24 divided by 4 is -6. Then my other part here, I'm going to multiply 4 times 3 as well and divide that by 4. Well, I just happen to know that when I do that, it cancels out the 4s. So when I do that, I'm left with just 3. Here again, I think you guys should notice that I've got all 8s here, 2 more 8s. And when I do that, I'm just going to, that 8 over there in Q is going to end up being a +6. And all these 4s in this problem are going to end up being 3 because that's what we solved for. So when we do Q prime, that's going to end up being -3, 6. And R prime is going to end up being 3, 3. Because we solved for 1, we can use them for all the rest. Then we're going to plot those points. And here again, I want you to notice that if I start drawing through these vertices, and by the way, this point over here should be R prime and R prime. This should be R prime and R prime. So when we do that, if we start drawing through these vertices and keep extending that line out, draw through these vertices of Q and Q prime, R and R prime, again, where those 3 points intersect is again at our origin. So on this problem, as with the previous one, we can say that this is a dilation of a scale factor of 3, and it's dilating from the origin. These are our new points, and we already had those up there, -6, 3, -3, 6, 3, 3. Okay, So here's the last one. I want you guys to go ahead and do this. And I want to remind you guys that multiplying by 1/4 is the same as dividing by 4. So you guys should all be able to do this one pretty quickly. So after dividing all the points by 4, we get -2, 0, -2, -1, -1, 2. And again, if you draw this on your paper for both of these, both DEC and DEC prime, we again should see that when we draw those lines between those from those vertices of D and D prime, E and E prime, and F prime, that they all meet at the origin. This again tells us that this was dilation from 0, 0, and we know that the scale factor is 1/4 because that's what we multiplied by. So with example 3, we're going to determine whether the polygons with the given vertices are similar. So now I need you to plot A, B, and C, and then I need you to plot H, J, K, and L. Go ahead and do that, pause the video, do that, and then come back to me and we're going to talk about what we see. Okay, so hopefully you're coming back to me now. So let's talk about what we see in this drawing. So our original ABCD, we have, and this is actually not labeled right either. This should have been A, this should have been B, that's C, and that's D. Okay, so when we start looking at this shape, AB is 9 tall, and JH, or HJ, is 3 tall. So again, we're going to take our new image over our original image, and that's going to give us our scale factor. New image over original image. And then we can look at the other side as well. And we should see here again that this is that BC is 9 and JK is 3. So again, new image over original image, we still get 1/3. So, and our properties that determine whether something is similar, first is that they all have the same angles. Corresponding vertices have the same angles. And all of these angles are right angles, so that first condition is met. Second condition is that we get the same ratio on all the sides, and that's true here as well. So we can say that it says determine whether the polygons with the vertices are similar. The answer is yes, because all the angles are congruent and because the sides produce the same ratio. So again, it says yes here, ABCD maps to JKL by a dilation with a scale factor of 1/3. So let's go on to the next one. This one, I need you to plot P, Q, R, and S, and then I need you to plot W, X, Y, and Z. So while you're doing that, pause this video and go ahead and do that. All right, so now come back to me, hopefully. So now we're going to compare some sides here. So I want to compare the vertical side to the vertical side. So the vertical side of QP over here is 4 tall, and the vertical side of XW is 10 tall. So again, we're going to take our second image and divide it by our first image, and that gives us a scale factor of 2.5. Now we want to compare the other sides. So we're going to compare QR, which is 2, to XY, which is 3. Again, we're going to take our second image over our first image, and that gives us 1.5. So immediately everyone should notice that these are not the same scale factor. Now we do have our first condition that is true because these are rectangles, and rectangles, the definition of rectangles, they have 4 right angles, so the angles are congruent. However, the sides do not produce the same ratio. So as a result, we have to say no, because the scale factor of one pair of sides is 2.5, but the scale factor of the other pair of sides is 1.5. So they don't have the same values. Excuse me. So we can't prove that these are similar. The next one is a U-try. I need you guys to go ahead and plot this one. Plot ABC and plot DEF. Pause the video and go ahead and plot them and then come back to me. Okay, so hopefully you've plotted ABC and DEF. Now, I want to again compare the sides here. So I'm going to compare AB, which is 1, to DE, which is 2. So again, take my ending over my beginning. That's a scale factor of 2. Now we're going to look at the height. So we're going to look at AC, which is 2. and we're going to compare it to the height of DF, which is 4. Again, take our ending, our second image over our first image, and that as well is 2. So we do have the same scale factor here with these two triangles. However, if we were to try to scale, if we were trying to just scale this, if you notice, if we multiply 1 by 2, we should have gotten 2 for D prime, if that's what happened. But that's not what we have. We have 4. Same way with the rest of these. So when we look at an image like this, we can see that our original image is congruent with our or I should say similar to our new image because of the scale factor. However, we didn't just get there by multiplying everything by 2. In this case, we moved it first. So we moved this point A down to A prime. So we moved it 1, 2, 3, 4, 5 down, and we moved it over 1 to the right. So actually this image moved 1 to the right first and then 5 down. Then it was scaled. So the answer here is yes, ABC maps to ABC prime, but it was translated first. 1 to the right and 5 down, and then it was dilated by a scale factor of 2. All right, this next one is our circles. So what I want to do with this one is talk to y'all about how first you graph a circle. So the easiest thing to graph a circle is to go ahead and plot the center and then plot out the radius from it. So I'm going to count 1, 2, 3 to the right, 3 up, 3 to the left, and 3 down. And then I'm going to draw my circle through those points, those 4 points that I got right here. This one, this one, this one, and this one. That's how you can get a fairly good circle. Okay, now let's talk about what happened here. First of all, in this drawing, the center moved. Hopefully everybody sees that the center moved up. 1, 2, 3, 4, 5, 6. It didn't move left or right, but it did move up. So we could say that the center moved, X part didn't change, but the Y part did change. It moved up by 6. So that's the first thing we notice. Now, when we're talking about scale factors for circles, though, we're going to talk about the radius. So the radius of the first one is 1, and the radius of the second one is 3. So again, we're going to do the same thing we've been doing all along. We're going to take the second image over the first image, and so that produces a scale factor of 3. So this is how we find the answer to this question, and it says what happened here. So are these circles similar? And yes, they are. And frankly, all circles are similar. So that's pretty easy to figure out. So let's look at this next one. Again, this time we got our, and by the way, this up here is wrong. It should be -3, and I think it's wrong on y'all's paper too. It should be -3, 0. That's what should be on your paper, because that's where that circle is. The center of that circle is at -3, 0. And then it talks about, it has a radius of 2. And then we're going to talk about this other one. And again, its center is at 1, 2, 3, 4, 5 over, and 1 up. That's over here. And as I said before, with this radius, I'm going to go 5 to the right, 5 up, 5 to the left, 5 down, and I'm going to draw my circle through those 4 points. Now let's talk about where this center moves this time. So if we look at this, it moved 1, 2, 3, 4, 5, 6, 7, 8 to the right. So that would be X plus 8. And it moved 1 up. So that's going to be Y plus 1. So that is our translation of the center. Then we have to talk about the scale factor. So again, we're going to compare the new radius to the original radius. So we're going to pick our new shape, 5 over 2. And 5 divided by 2 is 2.5. So again, this is how these shapes transform, and it is a dilation of with a scale factor of 2.5. And to get that, we compare the radii of the two circles. So hopefully this video helped you guys.